Module 4, Lesson 23, we're going to go ahead and look at looking at true or false number sentences. But first we need to look at what these symbols mean. So this symbol means equal to. And so you could say 5 plus 3 equals 8. This symbol means greater than, which would be, you could say 5 plus 3 is greater than 5, because 5 plus 3 equals 8, and 8 is greater than 5. This symbol means less than, and so you could say 2/3 is less than 3/4. And that 2 does not look like a 2, sorry. And this symbol, these last two ones are new ones that you're adding to it, and so this is less than or equal to. And so you would say that, you could say that 5 plus 3 is less than or equal to 8, because 5 plus 3 equals 8, it still makes it true. And then this one is greater than or equal to. And a statement that you could do with this one would be that 9 is greater than or equal to, let's say 35 divided by 5, because 35 divided by 5 is 7, and 9 is greater than 7. So we're going to go ahead and look down here. We're going to look at how to use variables to solve these, to say whether a statement is true. So your first one that I'm going to give you is going to be an equation. So the equation is 5 plus x equals 8. And then we're going to solve it for 3 equals, or x equals 3. So for x equals 3, we would solve it. That would be 5 plus 3, which does equal 8, so this is true. Now it would be false for all numbers that are not 3. Your second example is going to be 5x equals 8, which is 5 times x equals 8, and they're saying that x equals 3. So I'm going to take 5 times 3, which is 15. It's not 8, so this is false. And you can't actually multiply 5 by a whole number to make it true. So number 3, my third example, is going to be 5 plus x is greater than 8. For x equals 3, we plug it in. We take 5 plus 3, and they're saying that's greater than 8. I'm going to solve that. It's 8 is greater than 8, which is false. Now, if x was equal to 4, it would be true, because 5 plus 4 is 9, which is greater than 8. And then let's look at number 4. Your fourth example is 5x is greater than 8, which is 5 times x is greater than 8, and x equals 3. So that would be 5 times 3 is greater than 8, which would be 15 is greater than 8, so this is true. And for number 5, you have a 5 plus x is greater than or equal to 8, and x equals 3. And for x equals 3, that would be a 5 plus 3 is greater than or equal to 8. Solve for this side. That's 8 is greater than or equal to 8. It is true, because this means it can also equal it. Now, a couple other examples for you to write up here, just so you can see them in a couple different ways. You could write 5 and 1/4 is greater than or equal to 4 and 7/8. You could write 4 and 7/8 is less than or equal to 4 and 7/8. Because they're the same, that equal sign means that they can be the same. You can have 4 and 1/2 is less than 4 and 7/8. You can have that 5 and 1/4 is greater than 4 and 7/8. And lastly, you could have that 4 and 7/8 is equal to 4 and 875 thousandths. So really, there are multiple ways that you would use these symbols. So let's go ahead and go to this next page. I'm going to solve the first 3, and then you're going to solve the next 3 and check your work. And then once you check the next 3, you're going to do the rest, and you can do that with a partner. So for number 1, we have 4 plus x equals 12. Substitute 8 for x. Now up here it says if it's true, find the value that would make it false. And we need to make a sentence that would say it would be false if. Now if our answer is false, we're going to say what it would need to be to make it true. So we have a 4 plus x equals 12. It says substitute 8 for x. And so that means 4 plus 8. And we're going to solve that. That equals 12. That's the same. So this is true. And this would be false if this was a 5. Or if it were a 4, if it were a 9. Basically, if it's any number other than 8, it would be false. So this would be false for all numbers other than 8. Down here, we have 3g is greater than 15. It says substitute 4.5 for g. So this is 3 times g is greater than 15. And so this is going to be 3 times 4.5. Now before we can solve and with an improper fraction and a mixed number and a whole number, we need to make that an improper fraction. So I say 4 times 2, that's 8, plus 1 is 9. So this is actually a 3 over 1 times 9 over 2. That gives me 27 over 2. Now, I need to turn this back to a mixed number, so I'm going to take 27 divided by 2, that is 1. 7 divided by 2 is 3, remainder 1. And so what this comes out to, and so I'm just solving this side here, is 13 and 1/2 is greater than 15 is the statement, so this is false. And any number that would make 3 this side greater, so 3 times 5 makes it equal. So any number bigger than 5 would make it true. So you could say 6, 20, 1,000, any of that would be true. So this would be true for all numbers greater than 5. Then for number 3, just so that you know what they're doing here, this is division, remember, so a fraction means division, so that's f divided by 4 is less than 2. It says substitute an 8 for f, so I'm going to put 8 divided by 4. They say it's less than 2. 8 divided by 4 is 2. They say that's less than 2. That is false. And think of a number that f can be that would result in less than 2. 8 equals 2, so that means any number less than 8 would make our number bigger. So I could say 6 divided by 4. 6 divided by 4 is 1.5. 4 divided by 4 is 1. If I did 10 divided by 4, that's 5. So if I went bigger than 8, it wasn't true. But when I was smaller than 8, it was true. So all numbers less than 8 are true. Now, when you solve the rest of these, you don't need to say all numbers. You could pick a number. So if you said 6, if f equals 6, it's true. You could do that. If f equals 4, it's true. So if you wrote that, that still makes it true. This is just so that you know all the numbers that would make it true. So like I said, solve these next 3, check it. If you get these 3 right, go on. You can work with a partner to do these. And once you have them all right, you can get your exit ticket.